study, we sought to answer some of the common questions that we get posed by patients, particularly patients with blood cancers. They often ask us, how long have I had this cancer for? How fast did it grow, or is it still growing? So we wanted to address these questions. We took myeloproliferative neoplasms that are, or MPN for short, that are chronic blood cancers. They affect young patients, but more commonly they affect older patients. And we wish to ask in these patients, when are the cancer-causing mutations arising in these patients? And over what period of time is that cancer growing before the patient presents to clinic with disease? The way we did this was that we studied 10 patients with MPN. We took individual blood cells from either their peripheral blood or bone marrow, and we grew up each blood cell into a colony. And then for each colony, we undertook whole genome sequencing. The reason we did this is because our hematopoietic stem cells are accumulating naturally mutations over time, over our lifetime. In fact, the number of mutations within our stem cells reflects accurately how old we are. Older people have more mutations, younger people have less, and we accumulate roughly about 18 to 20 mutations per year. So that gives you a bit of a molecular clock. And by using whole genome sequencing across all these individual colonies from individual patients, we were then able to actually construct a family tree of the cancer and thereby trace back its life history right back to the birth of the patient. And we were then able to overlay onto that tree the cancer-causing mutations of the individual patient's blood cancer or their MPN. In doing so, we found quite unexpected results. Our intuition told us that mutations that cause MPN, such as JAK2 mutations, would be acquired some years before the patient presents to clinic. But actually, we found the opposite. These mutations are occurring very early in life. In most of our patients, the mutation